Hello and welcome. Have you ever had questions about space? Things like, what does this picture mean? Why is it called the observable universe? And what does this number mean? These questions and more will be answered in... Let's start simple, shall we? This is the Earth, with a diameter of 12,742 kilometers. It's quite big. Here's a human for scale. Can't see it? That's because on a 1080p monitor, a human would be 1/12,000th of a pixel. That is 1/5 the size of the bacteria E. coli. Zooming out, we would reach the size of Jupiter, the largest planet in the solar system. With a diameter of roughly 143,000 kilometers, Jupiter could hold up to 1,000 Earths. Zooming out even more, we'll reach the Sun. The Sun has a diameter of 1.3 million kilometers and can hold up to 1 million Earths. At this scale, the Earth would be no more than a speck of dust. Zooming out a little bit more, we would reach Sirius. With a diameter of 2.3 million kilometers, Sirius is 1 million kilometers longer than the Sun and twice as massive. Due to the star's luminosity being 25 times more than our own and the relatively close distance at 8.7 light years away, Sirius is the brightest star in the night sky. At this scale, the Earth would be the size of bacteria and a human would reach the atomic level. But the size of Sirius pales in comparison with Arcturus. Arcturus is 36 million kilometers across and is the brightest star in the constellation Boötes. A relatively old star at 7.1 billion years old, Arcturus expanded while using up its hydrogen core to 25 times its normal size. Interestingly, this is what the Sun will begin to do in the next few billion years. Zooming to an unreasonable degree, Betelgeuse is the next star. With a diameter of 1.2 billion kilometers, Betelgeuse is the 10th brightest star in the night sky, and after Rigel, the second brightest in the constellation Orion. Due to Betelgeuse's evolution, the star will go supernova in about 100,000 years. The explosion would be so bright that you could see it with the naked eye for more than a year, and would be as bright as the moon when it first explodes. The final star on our list is Stephenson 218, with a diameter of 3 billion kilometers. Stephenson is so large that it can fit 2.3 million suns inside it. A red supergiant, this star illuminates at 440,000 times more than our Sun. The diameter of Stephenson reaches all the way to the orbit of Saturn, which is a great transition into the scale of our solar system. Shrinking the Sun down to the size of a soccer ball, Mercury would be the size of the biggest bacteria found, called Theomargarita namibiensis. Venus and Earth would be the size of a grain of salt, at 1.9 and 2 millimeters respectively. Mars would be the size of a grain of sand, at 1.1 millimeters. Jumping to Jupiter, the planet would be the size of a blueberry, at 22.1 millimeters. Saturn would span 18.4 millimeters, about the size of a peanut. With the rings, it would be the size of a walnut, or 42.2 millimeters. Uranus would be the size of a pea, at 8 millimeters. The final planet, Neptune, would also be the size of a pea, at 7.8 millimeters. On the other hand, the distance from the Sun to Neptune is 750 meters, or 0.75 kilometers. Despite the diagram, the planets are actually incredibly small. In actuality, the solar system is mostly empty space. From this point on, the scales would become absolutely ginormous. Starting with the orbit of Neptune at 60 astronomical units, or 1/1000th of a light year, we will go to the smallest nebula ever found, the Jewel Bug Nebula. With a length of 0.2 light years, we can still see the orbit of Neptune. Zooming out, we now reach the Orion Nebula, which is medium-sized. At a distance from Earth of 1,354 light years, and being 24 light years across, it is the closest region of star formation from Earth and the brightest nebula in the night sky. Zooming out more, we see the Tarantula Nebula. This nebula is 1,862 light years across, and one of the brightest nebulas we can see. It is over 100,000 light years away in a distant galaxy. Also, this photo of the Tarantula Nebula was taken by the James Webb Space Telescope, which was released on Christmas of 2021 to observe distant galaxies that couldn't be observed by the Hubble telescope. Zooming out more, we will get to dwarf galaxies. This one is called NGC 5264 and is 11,000 light years at its widest. Due to its shape, it is considered an irregular galaxy, meaning it doesn't have an elliptical shape or a spiral shape. Zooming out, we get to our home galaxy, the Milky Way. With a width of 100,000 light years, the Milky Way is a moderately sized spiral galaxy. Our solar system orbits around the center of the galaxy and takes 250 million years for one revolution. The Milky Way also has 200 billion stars and is almost as old as the universe. Zooming out further, we get a cluster called the Virgo cluster. With a length of 15 million light years, we reach a considerable length. This cluster includes numerous elliptical and spiral galaxies, with concentration being 50 times more than the local group, which includes the Milky Way. Zooming out more, we reach the Virgo supercluster, which contains the Virgo cluster and other such denominations. A supercluster is a cluster of galaxy clusters. Basically, a supercluster contains groups of galaxies. With a length of 110 million light years, it's one of the more moderate superclusters out there. Nearing the end, we reach the Great Wall. Astronomers noticed an overdensity of gamma-ray bursts in a region of the sky. This then led to the discovery of a massive supercluster in the region. That supercluster is the largest known formation in the universe, with a length of 6 to 10 billion light years. Finally, zooming all the way, we reach the observable universe. The reason why it's called observable is self-explanatory, as it is the farthest we can observe. Due to the expanding universe, past the border the universe expands faster than the speed of light, meaning we will never be able to see past as the light won't be able to catch up. And that is the end of the scale model. Thank you for watching.